This is a continuation of the lecture about critical points and derivatives and how we use derivatives to find potential maximums and minimums. So we're going to start with a couple of graphic examples. This is a graph of the function f of x equals x squared. I can see I have a minimum here at the point 0, 0. The derivative of x squared is 2x. This is the derivative graph in green, and I see that it passes through the point x equals 0. So where the derivative equals 0 is where we have, in this case, a minimum. If I look at this graph, we did absolute extrema before. Today we're going to just do also include relative extrema. A relative extrema is a max or a min in an area. If I look at this graph, I have a maximum, a relative maximum right here, and I have a relative minimum down at the bottom here. They're not an absolute max or a min because the graph increases and decreases without bounds. But if I look, I can see that the derivative here would be 0 because the slope of the tangent line is 0. And the derivative here would be 0. Again, the slope of the tangent line is 0. That gives us a clue as to how we're going to find our critical points. We're going to take the derivative and we're going to set it equal to 0. So let's look at an example. So we're going to find the critical numbers for f of x equals 4x plus 1 over x. So the two places, there's another place we have critical numbers where f prime of x equals 0 or f prime of x is undefined, which means we have a denominator equal to 0. So I'm going to rewrite this as 4x plus x to the negative 1. I have not taken the derivative yet, so it's still just f of x. Now I can take the derivative, f prime of x equals 4 minus x to the negative 2, which is 4 minus 1 over x squared. Since I need to know potentially where my derivative might be undefined, I'm going to go ahead and write this as one fraction with a common denominator. That's going to be my technique. Then I will always set the numerator equal to 0, and I will always set the denominator equal to 0. My common denominator is x squared, so I'm going to multiply numerator and denominator by x squared. So I get 4x squared minus 1 over x squared. So to look for my critical numbers, I set 4x squared minus 1 equal to 0. I've got two potential ways to do this. I can factor and set each factor equal to 0, and I get x as plus or minus 1/2. Or I can add 1 to each side and get 4x squared equals 1. Divide by 4. X squared is 1/4. When I take the square root, I get plus or minus 1/2. Don't forget the plus or minus. My other potential critical numbers were x squared equals 0. And that's going to be true when x equals 0. So these are my three critical numbers. X equals 0, x equals positive and negative 1/2. If I wanted the actual point where those occurred, then I would have to substitute in those three values. 0 is going to give us undefined, and I could substitute in 1/2 and negative 1/2 to get the y values. For now, we're just going to look at the critical numbers, the x values, and that would be those three numbers. From the last lecture, I know that I'm guaranteed to have absolute extrema on a closed interval. To find the potential extrema, I'm going to first look for my critical numbers, And then I'm going to check the endpoints and pick the highest and lowest number for my absolute max and min. So if I have the function f of x equals x cubed plus 3x squared minus 9x plus 10 on the interval -4 to 2. Just like before, I'm going to take the derivative. F prime of x equals 3x squared plus 6x minus 9x. I'm going to set that equal to 0. That's how I find my critical numbers, which are where my potential maximums and minimums are. So I set 3x squared plus 6x, this should be minus 9, equal to 0. I see I have a greatest common factor of 3. I'm going to pull that out to make my life a little bit easier. So I've got x squared plus 2x minus 3 in parentheses. 3 cannot equal 0, so I'm going to cancel that out. At this point, again, as always with a quadratic, you either factor or use the quadratic formula. This factors into x plus 3 and x minus 1. So my two critical numbers are x equals -3 and x equals +1. From setting these two factors equal to 0. Now, to determine where my maximum and minimums are, I'm going to check the values of the critical numbers, and I'm going to check the values of the endpoint. And I do that by substituting into my original function. Because remember, maximums and minimums are the y values. So f of -3 is 37. F of 1 is 5. I just got those from substituting in. F of -4, now I'm going to check my two endpoints, is 30. And f of 2 is 12. I'm simply looking for the biggest number and the smallest number. This is my smallest number, so it is my absolute or global minimum. The 37 is my highest value, so it is my absolute or global maximum. And that's the process we're going to be following. If we're on a closed interval, we check the endpoints. Otherwise, we just find the critical numbers, and we're going to check and see if each is a maximum or a minimum or neither.